Well, let's practice a little bit more on finding the area of semicircles and some other shapes. In the previous videos, it was semicircles and a rectangle. In this one, we're going to have these beautiful three semicircles and an equilateral in the middle. So let's start with enlarging this semicircle in here. As you can see, the 2 represents the distance from the circumference to the circumference passing through the center of the circle. So this is the diameter. But what I'm looking for is the radius. And the diameter divided by 2 is gonna give us the radius. So in a semicircle, which is half of a circle, we need the radius, which is the diameter divided by 2. In this case, it's 2 divided by 2. So the diameter will come down to 1 centimeter. How did I know it's centimeters? Because it's mentioned in here that all dimensions are in centimeter. Since I know the radius, I can write now the general formula of finding the area of a semicircle. And the general formula is half of the area of a full circle. The area of a full circle is pi r squared. So it's going to be half of pi r squared. Let's substitute in this formula. Since r is 1, so r is going to be replaced with 1, and of it means multiply. So we wrote the general formula. Let's substitute using r as 1. So it's going to be half times pi times 1 to the power of 2. Let's write the final answer in terms of pi at first. So it's going to be half pi centimeter squared, or you can write it 0.5 pi centimeter squared. Let's write the final answer as a decimal number. And if you insert this in the calculator as half times shift and you press the pi button, you're going to end up with the answer of the area of this semicircle as 1.57 centimeter squared, and this answer is correct to 3 significant figures. Since we have 3 typical pieces of this semicircle, then this area must be multiplied by 3. But let's leave this step until the very end. Are we done with calculating each shape in this compound shape? No, we only calculated the area of the semicircle. And there is one more shape in here, which is the triangle. So we have 3 pieces of the semicircle. So this final answer must be multiplied by 3. But we're going to leave this step until the very end. Or you can do it here. This is totally up to you. So let's enlarge this equilateral. In an equilateral, we need 2 sides. We need the length of 2 sides and the angle in between. So in an equilateral, all sides are equal, all angles are equal. So if this side is 2, then the other 2 sides are 2 centimeters as well. So side 1 is 2 centimeters, side 2 is 2 centimeters, and since it's an equilateral, then the angle between any of the 2 sides is always 60. Okay, so the angle between the 2 sides is 60, and the general formula of finding the area of a triangle is half times side 1 times side 2 times sine the angle between the 2 sides. So side 1 is going to be replaced. We wrote the general formula. Now we're going to substitute in this general formula. Side 1 is 2, side 2 is 2, and the angle is 60. So it's going to be when we substitute half times 2 times 2 times sine of 60. If you insert this in the calculator, area of this triangle is going to be square root of 3. And the measurement unit is centimeter squared because all dimensions in centimeter, and any area, the measurement unit of any area is always millimeter squared, centimeter squared, meter squared, etc. So we have only one equilateral. If we analyze this shape, we have 3 typical semicircles and we have one equilateral, and the 4 shapes are brought together to make the final shape. So the area of this shape is 3 pieces of the semicircle. So it's going to be 3 times the area of one semicircle plus 1 piece of the equilateral, so plus the area of one triangle. Let's substitute here. So the area of semicircle, as we did previously, we are making a revision in here. But you can immediately say 3 times the area of the semicircle that we found in the first step, plus the area of the triangle which we found in the second step, and you're done. But I'm just trying here to revise or to summarize the steps that we made previously. So 3 pieces of semicircles times the area of one semicircle is half times pi times r squared. And r is 1. So this r is going to be replaced with 1. Plus the area of a triangle is half times side 1 times side 2 times sine of the angle between the two sides. Side 1 is 2, side 2 is 2, and the angle between the two sides is 60, so sine of 60. So if we substitute 3 times in brackets half times pi times 1 squared plus 1 triangle half times 2 times 2 times sine of 60. You can insert this one shot in the calculator and you can find the area of the total shape. Or you can say the area of one semicircle is 1.57 multiplied by 3 pieces, 3 typical pieces of this semicircle, plus 1 piece of this equilateral, so plus square root of 3. Insert this in the calculator. The final answer of the area of this shape, or the total area of this shape that is made of 3 typical semicircles and 1 equilateral in the middle, is equal to 6.44 centimeter squared, and this answer is correct to 3 significant figures. I would like you to think of this question on your own, which is made of, let me help you a little bit, which is made of one big semicircle, and as you can see here, we have three small semicircles. But when you find the area of the big semicircle and the area of one small semicircle, you're going to subtract the area of 2 small semicircles from the area of the big semicircle, and then you add to all this the area of one small semicircle. Please try to refer to the previous example to solve this example on your own, and watch the video a couple of times if you struggle with any of the steps. And I'm gonna say at last, thank you so much for watching, sharing, and subscribing to my YouTube channel.